Okay, so they have reached up to the third chapter. Okay, so we have to, okay, so we have to hurry them, right? Yes, so then this would be just like a recap class for you, right? Because you have already done this electric charge, and the second chapter is electric potential, right? So you have in your school, they already did. So this would be like what? This would be like a recap for you, right? So in the first few classes, and then I will try to pace up, and then I will try to reach or catch up to what they are doing in your school, right? So let us do these recaps first, right? So I will start with yes, yes. So first chapter, as you know, is what? Electric charges and fields, right? So in the first two chapter, the first two chapter talks about so the first two chapters are about yes. So the first two chapters are about electrostats, right? Meaning that electro meaning charge, right? And the second is part of this word is rest, right? So in the first two chapter, in the electric charges and field, right? Electric charges and fields, right? And the second chapter, electric potential, you will study about the charges which are at rest, right? So the properties that are associated with the charges at rest, so those property you will study in these first in these two chapters, right? And then when the charges are moving, so then you will have some current, right? And then that current will have some electric field, or let's say then a magnetic field, right? So all the other properties. So that properties you will study in electric current, right? So in your first part of your physics book, you have first you have electrostats, right? Electrostats, and then you have electrodynamics, right? In which you study about the moving charges, and then you have this magnetism, right? And then you have AC, right? Alternating current, and then you have some waves also, electromagnetic waves, right? So fifth is electromagnetic waves, right? So this is about the first part of the book, right? And these covers 70% of your syllabus, approximately 60 to 70% of your physics part one book, right? So these chapters are very much important, right? And then in your second book, you will have optics, right? The ray optics, the wave optics, then dual nature of those particles, structure of atom, right? So those part will come in the, and then in lastly, you will have semiconductor devices, right? So those part come in the second book. So what my goal would be in next few months to concentrate on these five important topics, right? So they cover approximately 60 to 70% of your syllabus. So if you know these, then you can score good marks in your school, right? So let us study about the first chapter. First chapter is the electric charges and field, right? So the first thing that one would ask about this electric charges and field, that what is a charge, right? So first thing is what is a charge? Okay, meaning the definition of a charge. So the answer would be that it is an intrinsic property of the material, right? Of the material or the element or the compound, such that, or by virtue of which, one experiences electric force, right? Electric fields, right? And energies associated with it, right? So this is the definition of charge. So first point to remember in this part is that it is an intrinsic property, right? It comes with the body, with the material. So whenever you have some mass, then the charge would so it will have automatically a charge, right? Whether it is negative or whether it is positive or whether it is neutral. So that will depend upon the number of electrons and protons, right? So that will depend on that. So this is about the definition of charge. So the most important thing to remember is that it is an intrinsic property, right? And second things are what? The basic features of charge. So basic features of charge, right? What are those? So the first thing is that it is a scalar quantity, right? It is a scalar quantity. And what do you know about scalar quantity? You know that scalar quantity can be represented by only a number, right? They only require some magnitude. They don't require some direction or anything else. So let's say what is a scalar quantity? One example would be what? The temperature of this room, right? So the temperature of this room can be represented by a number. Let's say 25 degrees C, right? So any physical quantity which can be represented by some number is called the scalar quantity, right? So the charge is a scalar quantity, right? And it can be represented by some number, right? So the second feature is that the SI unit of charge is what? Is Coulomb, right? So the SI unit of charge is Coulomb, right? And it is represented by C, right? So this is the SI unit of charge. And the third property, the third feature, these are not the properties, but the features of charge. The third feature is that the smallest charge material can have is charge on one electron, right? And that is what? E. So smallest charge can be E. And what is the value of E? So what is the value of E? So one E electron has 1.6 into 10 to the power minus 19 Coulomb, right? Yes. Yes, right. Absolutely right. So this is 1E, right? And this could be plus or minus depending upon whether you have proton or electron, right? So one proton has how much charge? 1 point plus 1.6 into 10 to the power minus 19 Coulomb. And one electron has how much charge? This is 1.6 into 10 to the power minus. Right. So this is about the smallest charge that a material can. Right. And what are the other features? So whenever you have a neutral atom, so an isolated atom is always neutral, right? So an isolated meaning that it is not reacting with other atoms, right? So if it will react with other atom, then it will acquire some charge. But if you have an isolated atom, so that means that that atom is always neutral. Meaning what? Meaning what? Let's say you take an example of, let's say sodium, right? Sodium atom you have. And in sodium atom, you will have how many number of protons? So when you study the structure of sodium, you will have the number of protons would be 11, right? Because it has the atomic number 11, so the number of protons would be how much? 11. And this is isolated, right? So this will also have number of electrons equals to 11. Right, so that is why it is neutral, because you have 11 E charge and you have minus 11 E charge of electrons. So the total charge would be how much? 0. Right. So that is why all the isolated atoms are neutral. Okay. So these are the basic features of charges. Right. That it is a scalar quantity, SI unit is Coulomb, and the smallest charge that a material can have is 1 E. Right. And an isolated atom is always neutral, right? So these are the basic features of charge. And the other thing is about charging, right? How can you charge a material? So you can charge a material by transfer of electrons or redistribution of electrons. So you can charge a material, or a material can acquire some charge by transferring of electrons or redistribution of electrons of charges, right? So that is how you can charge a material, right? And method of charging is not in your syllabus, so I will skip that. Okay, right. So any question up to this point? So these were very trivial. So these were like some recap of your electric charge, right? So then we will study about the properties of the charges, right? Yes. Yes. So let us move on to the next topic. So the next topic is the property of the charge, right? What are the properties of the charges? Yes, so property of the charges. As you all know, what is the first property of the charge? So property of the charge, right? First property is the quantization. Quantization of charge. What do we mean by quanta, right? Quanta meaning one small number, right? So that is one integer number, one quanta, right? So quantization of charges meaning that charges are integral multiple of charge on one electron, right? So the smallest charge that can a material have is how much? E, right? And that is called one quanta, right? One quanta. And the total charge of a material would be the integral one, right? So here n represents some integer. So that is why you are saying the integral multiple. Integral multiple meaning that you will always have charges like 4e, 3e, minus 2e, or let's say plus 16e, right? You will not have charges like 2.5e or let's say minus 3.4e. So these kind of charges you will not have in the nature, right? Because all the charges are integral multiple of this small charge, right? So this is about the quantization of charge. Okay. And then you have the conservation of the charge, right? So what is conservation of charge? That you know that charges can neither be created nor be destroyed, right? It can only be transferred from one reaction to other, right? So whenever, let's say, you have some reaction is taking place, right? Then charges can be transferred from one reaction to another reaction. Let's say in the you let's say you have sodium chloride, right? And that breaks. So sodium will acquire a positive charge and chlorine will acquire negative charge, right? So, but the total charge will remain the same, right? So in the reaction, in the particle reaction, the total charges will always be conserved, right? So this is about the conservation of the charge. Okay. And the third property is the additive nature of the charges, right? So the total charge on a material is the algebraic sum of the individual charges, right? Is the algebraic sum of the individual charges. Right, let's say you have a system in which you have, let's say, plus 3 electrons, right, charge, and then you have 2 electron charge, and then you have minus 4 electron charge, right? So what will be the total charge then? So this would be simply, you can add them, right? So this would be simply E, right? You can simply add these three charges, right? You will not have to do some transformation and or any other thing, or you have to not look about the vectors or any other kind of stuff, right? You can simply add them, right? And the total charge would be just the algebraic sum, not the vector sum, right? When you have some vectors, then you think about the vector addition. But for the case of charges, you just have to say think about the algebraic sum, right? You just add these three. Right? So this is about the additive nature of the charges. And the next thing is the invariance of charges. So this is a very important property. right? So charges doesn't depend on the velocity of the system or the frame of reference, right? Right. So let's say if in a car you have some 3 coulomb charges, right? And if a car travels at some distance and it is moving with some velocity, right? So the charge will always be 3 coulomb charge, whether you look from the inside the car or whether you are outside the car and you are looking at inside the car and measuring the charges, right? So all the people will measure the same charges, right? But this is not the case of, let's say, the velocity of ball in the car, right? So let's say if the ball is moving inside the car, but when the person is looking from the outside, so it will see that moving, and when the person is looking from the inside, so this they will not see it moving, right? So that depends upon the frame of reference, right? But charges are invariant like that. So charges doesn't depend upon the frame of reference, whether you are moving or whether you are stationary, right? They will all measure the same charges. So these are the 4 important properties of charges, right? First property is that the charges are always quantized, right? Second property is the conservation of charges, that in a reaction, charges can never be created, right? Out of nowhere, you can't create a 1 coulomb charge. So it can always come from one reaction to another reaction. It can transfer, right? Charges can transfer, but it can never be created out of nowhere. And similarly, you have the additive nature of charges, that you can add simply, you can calculate the algebraic sum of the charges. Okay. And the fourth property is that the invariance of charge, right? That whether you are in one frame of reference or in the second frame of reference, right? So you will always measure the same charges. Okay, so these are the basic 4 properties of the charges. So any doubt in this? Any question up to this point? These are all basic trivial things, right? I want to reach up to Coulomb's law in this class, right? Because that's when the real physics come, right? So any doubt up to this point? Oh, okay, okay, yes. So fourth, okay, yes. So yes, the fourth property is also the important property, guys. When you go into the higher classes, you will learn about that so you have some Lorentz transformation, you have some kind of rotational transformation, right? Other kind of translation. And in all those transformation, the values change, but the charge will not change. So this property is important one, right? Like mass. So when you move with some velocity and your velocity is very high, so at very high velocity, your mass will change, right? So mass is relativistic, right? So, but charge, whether you are moving with the speed of light or whether you are moving with a charge, it doesn't depend upon the velocity, right? Yes, so let us do one or two problem based on these 4 properties. So one question that everybody, yes, yes. So one question that everybody asks is that what, how many, so how many electrons have 1 coulomb charge? How many electrons have 1 coulomb charge? Or you can interpret it as how much 1 coulomb charge means, right? So if you have 1 coulomb charge, then what would be the number of electrons, right? So these are some important questions that they ask in your CBSE exam, right? So how can we calculate that? So the charge is given, right? Charge is given, which is 1 coulomb, right? And we know the relation that the charge is equal to NE, right? We have to find this number of electrons, right? So this is the question. We have to find the number of electrons, right? So we know E, right? We know Q. This is given 1 coulomb. We have to find N. So this is 1 N. We have to find E. We know, right? So coulomb cancels, right? So you have N is 1 by 1.6 into 10 to the power minus 19. And if it goes upwards, so the power will become positive, right? So this will be 10 to the power 19 by 1.6, right? And you can take 10 from here. So this would be 10 into 10 to the power 18, right? And this is 1.6. So this would be how much? This is 16, or let's say 10 points. So this is 96, and you have 4, then you have 2, right? So this is 32, and you have what? 8, and you have so 8, right? So 6.25 into 10 to the power 18 electrons, right? So this 1 coulomb charge contains 6.25 into 10 to the power 18 electrons. So you can imagine how much bigger number of this. So 6.25 into 10 to the power 18, meaning 6 to 5. This is 2, 3, 4, 5, 6, 7, 8, 9, 10, or so on, right? 18. So this much, I don't know how much is this number. So let's say up to 18 times, right? This number of electron contains 1 coulomb of charge, right? This is a very big number. Okay. So this much of electrons contains 1 coulomb of charge. Any problem in this? Any doubt in this question? Yes. Okay. So now let us do the second problem, right? And second problem, you can take it as your homework, right? So take it as your homework that let's say how many positive charges are there in, let's say, 635 gram of copper, right? And the atomic number of copper is how much? 29, right? Cu 29, and the mass number is how much? 63.5. Right. So this is the information you have. You can calculate how much positive charges are there for this 635 gram of copper. Right. So this you try, and we can discuss this in the next class. Right. So this, take it as your homework. Okay. So did you take the screenshot of this question? So yes, please take the screenshot, and we can discuss this in the next class. Okay. Yes. So the next topic is Coulomb's law. Right. So you have we were talking about one charge only, right? So we have, let's say, one charge. And what happens when you have two charges, right? So what happens when you have two charges separated by some distance, right? So in your 11th class, right? In your 11th class, you must have learned about. So you must have learned about the Newton's law of gravitation, right? So what did you learn about the Newton's law of gravitation? That whenever you have some mass, let's say m1, right? And whenever you have the second mass m2, right? So they will try to attract each other, right? So this will attract this way, this will attract this way, right? With the same magnitude. And let's say if this separation is r, so Newton's law states that according to Newton's law, the force between them will depend upon the inverse of the square of the separation, and this will depend upon the product of the masses. Right. So then Newton's gave the theory that your F would be m1, m2 by r square. Right. This is the magnitude. We will talk about the direction in the next class. Right. So similarly, Coulomb's law. You have Coulomb's law. Right. Coulomb's law states that Coulomb's law is about the charges. Right. We discussed about these masses. If you have some masses, what happens when you have some charges, right? Let's say this has some charge q1 and this has some charge q2, right? So they will also experience some force, and the separation between them is r, right? So coulomb's found out that the force would be inversely proportional to the square of the distance between them, square of the separation, right? And he also found out that this will always proportional to the product of the charges, just like the Newton's law, right? So when you omit or when you remove this proportionality, so there would be a proportionality constant k, right? So you will have k q1 q2 by r square, right? So this is the electrostatic force, right? Whenever you have charges, and the separation between them is r, so they will experience this kind of force. Okay, so this was given by Coulomb, right? And one more thing is that what is this value, right? So k is 1 by 4 pi epsilon naught, right? So this is 1 by 4 pi epsilon naught, where your epsilon naught is what? This is permittivity of free space, right? So this we are talking about in the air, right? So this is in the air. The whole system is in the air, right? But whenever you place, so this system is in the air, okay? But whenever you place this system in some medium, right, the force will decrease. Okay. So whenever you place this q1, q2 charges in some medium, right? Let's say this is in some medium. Okay. Let's say this is in some medium. So then your force will decrease by a factor called so this is 1 by 4 E and Q1, Q2 by R square, right? where this E signifies the permittivity of the medium. And this permittivity of the medium can be written as 4 pi ER epsilon naught Q1 Q2 by R square. You can write ER or you can write K, right? So you can also write 1 by 4 kappa epsilon naught Q1 Q2 by R square, right? And here your K is called the dielectric constant. Right. So this is called the dielectric constant. So you see that in air, this was the force, right? So in air, what was the force? Force was 1 by 4 pi epsilon naught Q1 Q2 by R square, right? So this was for air, right? And you can see that 1 by 4 pi epsilon naught Q1 Q2 by R square, this comes here. So you can see that 1 by 4 pi epsilon naught Q1 Q2 comes here, right? So this would be F medium would be, this term is how much? F air by K, right? So now you see that your force is decreased by some factor K, right? This is the dielectric constant. Understood up to this point? So you have some Coulomb's law, right? You have two charges and they are placed in air, so they are experiencing some force, right? And when you put that those two charges in some medium, so then you will experience a decreased amount of force. And how much that decrease? So that is decreased by this dielectric constant. Okay, understood up to this point? Yes, so this was about the Coulomb's law, right? And so let's do one problem on Coulomb's law, right? Let's say you have one charge, you have one charge which is let's say 3 coulomb, right? And another charge is placed at another charge which is let's say 4 coulomb, right? 4 coulomb is placed at a distance, let's say uh, 3 meters, right? Then what would be the force? So what would be the force, right? So what would be the force? We know from Coulomb's law, this would be simply K Q1 Q2 by R square, right? And the value of K is how much? This is 9 into 10 to the power 9, right? And what would be the unit? So the unit of force is how much? Newton. This is meter square, right? And divided by Coulomb square. So this is the value of this K. I'd always remember this value. So you have K, which is 9 into 10 to the power 9. Q1 is how much? 3 coulomb. And second charge is how much? 4 coulomb by 3 square, right? 3 square is 9, so 9 cancels. You have 4 threes are 12 into 10 to the power 9 Newton, which is what? 1.2 into 10 to the power 10. Right, so this is the force. Okay. So let us stop here, right? And in the next class, I will be doing some questions here. Yes. So if it is not mentioned that whether this is in the air or in the medium, so we would always assume that it is in the air, right? Because you don't have the dielectric constant given, right? So if you are given the dielectric constant, then it means that it is in some medium, right? But whenever you are not given the value of the dielectric constant, that means that it is in the air. Okay. Yes. So let us stop at here, and from the next class, I will talk about the Coulomb's law, some more question based on Coulomb's law, and then I will talk about the superposition. Let's say we calculated the force due to one charge, right? One charge was placed, and we placed one charge in the nearest to that, and then we calculated the force. Now, so then what happens when you place multiple charges, right? So then you will have to use the superposition principle, and we have to calculate force due to all the individual charges, and then we will use the vector addition property, right? So in the next class, I will be talking about the vectors. Vectors you already learned, right? But I will do some recap of the vectors, right? Because vector is very important in electric charge and field. So whenever you calculate the force, or whenever you calculate the electric fields, right? So you will need the vectors property, right? So yes, so let us meet in the next class, and then we will start from here. Okay. And please work on your mic, right? Because in the next class